Did the Challenger disaster change the world of communication, or even influence it? The Space Shuttle Challenger disaster occurred on January 28, 1986, after launching from Cape Canaveral, Florida. After 73 seconds into the flight of the Challenger, there was a failure in the joint of an O-ring on a solid rocket booster, leading to the explosion of the Space Shuttle Challenger. Before I discuss the communication failures that occurred in the Space Shuttle Challenger disaster, I want to introduce a few environmental regulations that are required for the launch of the Space Shuttle. The weather near or on the launch pad must meet certain criteria for liftoff. Before the tanks of the Space Shuttle begin loading propellant, also known as tanking, the temperature over the past 24 hours must not have dropped below an average of 41 degrees Fahrenheit or exceeded 99 degrees Fahrenheit for a consecutive 30 minutes. Also, tanking will not occur if the wind is observed to be over 42 knots for more than a 3-hour period. In addition, if there is any rain in the flight path or at the launch pad, the launch will be delayed. Lastly, tanking will not begin if there is more than a 20% chance of lightning within a 5-mile radius of the launch pad. As we know, environmental factors can put a strain on everyday events, including space shuttle launches. However, in the Space Shuttle Challenger disaster, there was multiple incidences of miscommunication between the engineers and the launch specialists. A main miscommunication was over the effects of the environment on the O-ring applications. Alan McDonald, one of the head engineers at NASA, did not sign the launch recommendation the night before because of his concerns due to the weather and the astronaut safety. The temperatures were not ideal for the most effective launch of the space shuttle. Just 2 nights prior to the scheduled liftoff, the temperatures reached record lows. McDonald and other engineers discussed these factors with the launch control specialists, yet they still decided to launch because all of their data fit inside the specified parameters. Unfortunately, the engineers did not have substantial evidence to persuade the launch specialists that the launch should be postponed. The issue arose when it came down to the importance of the mission schedule versus safety concerns of the astronauts. The engineers collected weather data that did not comfort them in the decision to launch. Yet, the average of temperature still met all the requirements to launch the next day. The Space Shuttle has 2 solid rocket boosters, each made up of a nose cap, parachutes, computers, 4 fuel segments, 3 separate sets of O-rings, a nozzle, and an AFT skirt. The image on the left of a solid rocket booster shows all the components. The image on the right displays the area where the failure occurred. As mentioned before, the Challenger disaster was due to a failure in the O-rings between the 2 lower segments of the right solid rocket booster. Researchers have found that the O-ring's resilience is directly related to the temperature. A warm O-ring, around 75 degrees Fahrenheit, will return to its original shape much faster than a cold O-ring at 30 degrees Fahrenheit. On January 28, 1986, at 11:38 a.m., the temperature in Cape Canaveral, Florida was 36 degrees Fahrenheit. 2 nights before the launch, the temperature had reached a record low of 20 degrees, creating a colder atmosphere for the O-rings to adjust and leaving icicles days prior to the launch. After years of research, investigations, and interviews, people still ask, could the Space Shuttle Challenger disaster have been avoided? Even though no regulations were disobeyed, the issue still comes down to the mission schedule versus safety precautions. The temperature was the main source of concern in the accident, which was uncontrollable by any one party. Researchers claim that if the temperature was warmer, there would have been a less likely chance the Challenger disaster would have occurred. The miscommunication happened between the engineers focusing on the safety precautions and the launch control specialists focusing on the mission schedule. However, today, there are more than 2 parties who decide if it is safe to launch. In everyday life, there are conflicts that arise and miscommunications do occur. However, to decrease the amount of miscommunication in your personal life and in the business world, we should try to be more understanding and make educated decisions that will keep the schedule on track, yet still abide by the safety regulations. Therefore, next time you find yourself making a decision, take all aspects into consideration before making a final decision.